Hello class, this is Mr. McAllen, and what I want to do today is I want to go over what we did last week with our sequences and series that was in section 10.1. And the purpose of this is just to remind you of a few facts that we went over. And the first thing we're going to start off with is what is a sequence. And a sequence is just a set of numbers that may follow a pattern, and it's separated by commas, and usually with a sequence there's some sort of a pattern associated with it. For example, if I gave you a series of numbers that was 2, 4, 8, 16, 32, and dot dot dot, meaning so on, this obviously has a pattern, and the way we like to number this pattern or keep track of this pattern is with a notation where we say that a to the n represents an amount in the sequence at a certain location, and n tells us the location. So for example, in this sequence that I just drew, this location would be n equals 1, this would be 2, this would be 3, 4, 5, and so on. Sometimes when we see a sequence of numbers, we'd like to just guess the next few numbers in the pattern. So hopefully from looking at this pattern, you can guess that the next one will be 64, the one after that would be 128. But if we don't want to keep on guessing all the numbers in the pattern, sometimes what we're given or we figure out is a sequence equation. So for example, for this sequence equation, this would be 2 to the n for our sequence equation. So at any time, whenever you want to find any value for the sequence, whether it be the first, second, third, or even 10th or 100th term in the sequence, if you want to find the 100th term, you would just plug in 100 into the sequence value, and you would solve for that value. So in this case, 2 to the 100th would be quite an enormous number. It would be 1.267 times 10 to the 30th, and that's not even exact because the number is so large. But so be careful with the n values you choose for your sequence. Another type of problem that you had to do last week was you had to figure out, they would ask you, given a certain sequence equation, can you find the first 4 terms, and maybe can you find like the 10th term? So in this case, what you had to do is you had to just write out each term and make sure you first write it out explicitly. So I'm just going to demonstrate one, and then I'll go offline to do the rest and show you the results. So on the first one, -1 to the first power times 2 times 1, and that would equal any negative number raised to an odd power stays negative, and this would be times 2. So your first term in the sequence would be -2. The next term would be, -1 squared times 2 to the second, and that would be +1 times 4. And the next term would be -1 to the third, 2 times 3, which would be -6, and so on. So I completed the task at hand here, and as you can see, our sequence values change from -2 to +4 to -6 to +8. So hopefully you recognize that there's a pattern going on where every odd sequence term is negative and every even sequence term is positive, and you follow the idea of finding the sequence value at specified n values. The next thing we did in this lesson was we talked about what a sum and series were. Okay, a So when we have the sequence term, let's say -2 plus 4 minus 6 plus 8 dot dot dot, and they're separated by commas, we call this a sequence of numbers. But sometimes we'd like to know what the summation of those terms would be. So we would call this we would talk about finding the sum of the sequence, or sometimes we call this finding the series. So for example, if we have if they said to us to find a partial sum, they would note that with an S instead of an A this time, because remember the A stands for the amount at term 10 for A sub 10. But when they ask us to do the sum of 10, that would mean the partial sum of the first 10 terms. So we would be expected from this notation to write out -2 plus 4 minus 6 plus 8 once we understand the pattern, and then we keep on going. -10 plus 12 minus 14 plus 16 minus 18 plus 20. So then we would sum up these terms. So either use your calculator or you would just do this by hand. For these two you would have 2. Then you have 2 minus 6 and you would get -4. And then you would add 8 and you would get 4. And then you would add -10 and you have -6. Add 12 you would have 6. Add 14 you would have -8. Add 16 you would have 8. Add -18 you would have -10. And when you add it to 20, your final sum amount would be 10. So that's how you would proceed through a partial sum. They could ask you a variety of different partial sums. If they ask you the partial sum of 8 terms, of 3 terms, it's basically just add up those number of terms. Then we move on to finding what sigma notation is. The sigma notation is a way of representing a summation, but it's a little bit more, it has a little bit more information in it. It's a little bit more flexible. The lower number tells you where to start adding. So here we're going to start at the first term, and then we're going to go up to the fourth term, and we may just do this summation. And but what I have to put in here is the general sequence term. So I'm just going to look back at what we had before, and that was -1 to the n raised times 2 to the n. So I would put -1 to the k, and then have 2 times k for my term inside of the series. And this would be represented, what I would have to do for each one is I would have to first do k equals 1, and that would be -1 to the first power times 2, plus -1 to the second power times 2 times 2, plus -1 to the third power times 2 times 3, plus -1 to the fourth power times 2 times 4. And I'm just making a notation on the top here. You don't have to really do this, but it just helps for illustrative purposes for me to put the different k values. And that's what the sigma notation means. The sigma is the Greek letter for S, which is used for to represent summing up. You can start your sigma at any value. You could start it at 10, and you can have it go to 12, and then you'd only have to sum up the first, the 10th, 11th, and 12th term. So this summation would look like -1 to the 10th times 2 times 10, plus -1 to the 11th times 2 times 11, plus, and hopefully by this point you're thinking this isn't really so bad. This is just at times a bit tedious, but with this type of problem it's better to write everything out at first and then compute what the different values are. For instance, -1 to any even power is 1, and this would be 20. This would be odd, so this would be 22, and this would be even again because of an even power, and this would be 24. And when you add up these numbers, you get 20 minus 22 plus 24, and the summation of that would be 22. For one last problem, we have a, let's just do a word problem which talks about cell division. So what we have here is a single cell divides every 20 minutes into 2 cells. Give a sequence list for the first 3 hours which details how many cells have been created. So what we would do in this is we would just start writing out the terms. If we start out with 1, so I'll just write a to the 1 equals 1. And remember, every 15 minutes or every 20 minutes we've divided that cell into 2. So the next one would be 2. In the next 20 minutes we would be at 4, and so on. So I'm just going to write out, because I can follow this pattern pretty easily. Now, what I want to do is I want to look at see how many intervals I have, because it divides every 20 minutes, and they ask for the first 3 hours. Because there are 3 20-minute periods in an hour, I really only need to go to here. This would be 15 minutes. This would be 20 minutes. This would be 40 minutes. This would be 60. So that would be 1 hour. So I just need to go up to basically, this would be 80 minutes. I need to go up to my 9th term. This would be 100 minutes. This would be 120 minutes. So now I'm up to 2 hours. And now this is 150 minutes. Oh, yeah, 140 minutes. 160 minutes. And then 180 minutes. So this would be my final amount that I would have at the end of 3 hours. Hopefully this video has helped you recap some of the things we did last week with sequences and series, and look forward to the refresher I do for arithmetic sequences and series. I hope you have a good day. Take care, guys.